Hi, and I'm going to apologize in advance because I woke up way too early this morning with a cold, and so I've had no coffee. I want to talk a little bit about Whois and why we use it every day and why we shouldn't use it every day. This all started as a project I did for PeeringDB, which was just seeking to get registration data in a programmatic way and essentially automate around it. It looked really good at first, but there are still a lot of inconsistencies between the RIRs. And they're really happy to fix things quickly. So the goal of this talk is get Swift to use RDAP. Please give them feedback. They fix things as fast as you can tell them. So it's really just, there's no reason not to be moving to this. The longer we take to move to this, the longer it'll take to get done. If everybody in this room switched to RDAP today, everything would probably be done within a month or two. And there's open source projects if you want to hack around on code a bit. So I'm briefly going to go over what Whois is and what RDAP is, and then give a few use cases. So Whois is a very simple ASCII protocol. It's so simple you can telnet to port 43 and do the exact same thing as your Whois client can. Then there's rWhois, which essentially delegates information. So instead of having one centralized source, you go to one server, it will give you X amount of information, and then say, well, here's another server you can also query to get more information. And what's wrong with Whois, which is quite a list. This is stolen from RFC 7485, which is one of the RDAP RFCs that basically compares Whois as it is today and where we want it to be. So it has no authentication possible. Like I said, it's telnet ASCII, return ASCII. No internationalization because of that, so no UTF or anything like that. The biggest problem in my eyes is no normalization. So each server will give you the information that you want, but it's in a different format. So if you're writing code to do this, in my example here, Aaron does camel case org name to get the organization name that owns an AS, or Wright does org-name. So it makes everything you do incredibly hacky with it. Which brings us to the Whois clients. Originally, before rWhois, this was a text file. So in my example here, and I can't read that far away, but there's 3 ASNs that go to write, and then 306 to 371, I think, go to nic.mil. Well, nic.mil no longer exists, and it's handled by Aaron now. So on a modern current install of CentOS, if you try to Whois AS306, nic.mil doesn't exist, so you get nothing. Those of us who use Whois every day probably have a bash RC file filled with functions that do things like this, that look up the correct source and make it nice for you. So it's not like it's impossible to make this work in some fashion, but it's certainly not the way we want to go forward. Which brings us to everything that's right with Whois. We use it every day. I can look up an IP address, I can look up an AS, I can look up a domain. I use the same tool to get the information that I want from one tool. Which brings us to RDAP, which is the Registration Data Access Protocol. It essentially takes all the data from Whois, gets a standardized method to receive it over HTTP with JSON. And there's currently 5 RFCs, and there's a few drafts on that, which I'll touch on later. And in this talk, in my examples and whatnot, I specifically focus on getting ASN information from the RIRs. So RDAP covers everything. I'm just not going to talk about the rest today. So why HTTP and JSON? Obviously, HTTP and JSON are widely used. There's many, many tools that use them, so it's almost a no-brainer to use that. The 300 code redirects in HTTP work perfectly for delegating information. And I was talking to somebody a couple days ago about this, and he brought up how much of a pain it was setting up a Whois server to take your data and put it out using their protocol, because there was, I believe, only one Whois daemon, and how much of a pain it was in contrast to HTTP and JSON are so widely used. I don't think you could find a programming language that it would take more than 10 lines of code to go from the database of your choice to a correct RDAP output. So it's significant benefits to operational costs. So, RDAP, like I said, it's all peer-reviewed through the IETF. There's RFCs, there's drafts coming. So instead of just doing a free-form ASCII thing where every IR can do their own thing, it's discussed, it's standardized, and it all looks good in theory. There's one server to go to, so you don't have to have client-side hacks. You can go to any of the servers, but they're all required to redirect you to the server that you go to. So for example, I can request information on an Aaron AS from RIPE, and RIPE will send me to Aaron, and vice versa. And it's just simple JSON, as I'm sure all of you are familiar with. You can curl and get a huge JSON dictionary. Excuse me. It also has entities, which is, for those familiar with like Whois foo, when you query a handle to get more information, it has the same concept and the same queries. So this is Coloclu. RIPE does not nest entities, and Aaron does. So the entity is just going to give you all the information on a person or organization. So RIPE gives you this handle, and then you query the entity to get the rest of the information. So this all started was with PeeringDB wanting to automate network signups, because we authenticate that each user actually belongs to the AS that they register. So we had a choice of using a client library that scraped to his data and tried to normalize it, which would be at the whim of the RIR, because even if the library works now, there might be a change later that they inadvertently broke it, which means that we just be out. Or we use RDAP, which is as of yet incomplete, but we know that the data we get is correct and will remain correct. So we obviously picked RDAP. All we wanted to get was all emails associated with the AS, and then the organization name, essentially. And I'm going to quickly go through the differences between the 5 RIRs. AFNRIC has email addresses. They have no role information. So a role is what this person does, what that entity does, so like administrative, technical, abuse, registrant. And they have no names on the orgs at all. So I get the AS info, but I don't know what company owns it. Sorry. Aaron does things pretty much perfectly. They have all the email addresses, they have the roles, and they nest the data so it's one query, which was the ones I started with before I realized the other RIRs didn't all work like this. APNIC has email addresses. It has roles, except it doesn't have the registrant role. So I can see who's the admin contact, who's the technical contact, who's the abuse contact, but I can't see who actually owns the AS. And their server's kind of wonky, and it's inconsistent. LACNIC is unique in that they actually delegate to Brazil, which uses RDAP as it's meant to. So if you query an AS from Brazil, let's say you can go to Aaron. Aaron's going to redirect you to LACNIC. LACNIC will then redirect you to Brazil, and this is all not known to you. It's just the HTTP redirects. So they have email addresses. They have no org info. And they evidently have 2 different servers running v4 and v6, which took me a few minutes to figure out. So queries against v4 work correctly, queries against v6 do not, which they are going to change. And then RIPE. RIPE has email addresses. They require recursive queries, so they give me a list of handles. And then you have to query again if you want information on the handles. And they have no organization data. So since we started this, LACNIC, within a week, had tested code, rolled it out to beta, and then rolled it to production to add email addresses, except for the v6 server in Brazil. RIPE said they will add organization info, but it's not completely standardized yet, so they want to wait and not start another one-off. So essentially, the things that need to be done for this are, we have a standard way to get data. Not all RIRs are giving all that data. So there's a standard way for them to give it out. They're just not necessarily outputting it, because I should be able to get all the same information I get from Whois via HTTP. And once they do that, we can just get rid of Whois. brings us back to the goals. It just takes people to use RDAP, complain to them, point out inconsistencies. They will happily fix it. There's ongoing working groups working on this as we speak, but without people using it, it's kind of hard to figure things out. And it contribute to projects and do that. So this is not RDAP. This is just an example of using HTTP instead of Whois. That's a slide that wasn't supposed to be there. When we released PeeringDB2, we took away email address, so we wouldn't publicly give email addresses unless you were logged in. And lots of people used the PeeringDB Whois server. So they complained that the email addresses were gone, and we said, well, it's not authenticated. We're not going to bring them back. But we can make you a client that works exactly like Whois, except it uses HTTP and JSON. So, which is what we did. So the two commands I have listed here are the exact same. The top one uses HTTP. They even use the exact same code. So the Whois server for PeeringDB uses the exact same code as the client does to output that as text. But if you're logged in, you also get email addresses. So if you're logged in, you have an API key in your config file, you will get email addresses just like that. So as far as I know, there's only two. The Python one, I literally just pushed this morning, so it's not very far along. Thank you so much. The Ruby one from Aaron is very mature. It actually already is starting to push to the next step of normalizing data and testing RIRs to make sure everybody outputs the correct thing. So when we're done, once this is all implemented correctly, the clients will produce the exact same as Whois. It'll just be using a different underlying protocol. But it will also be completely normalized, so any script or anything can use the same data without scraping and guessing. So the main two drafts, and I guess I'm way ahead of time here, I blame that on the throat, is Andy Newton at Aaron is doing a lot of work on this to actually bring the standards that now we have a standard way of getting the information, but now we're going to actually prove that they all give the information and give it correctly. It's sort of like a schema check. There is a whole mailing list of the IETF devoted to this. So if you want to get involved with that at all and have a better idea on how to do it, definitely jump in there. And that's pretty much all there is. Get rid of Whois and try something new out. Does anybody have questions?
Rüdiger Volk, Deutsche Telekom. I wonder whether actually making public and coordinate a common basic schema for the data is something that hasn't yet happened and actually would be very important for making use of the data.
Yep. And let me see if I can get back to that. That's what the top thing is, and I agree completely with you, and that's where it's at right now. So I think that's on stage 6 of the draft.
Kind of that question I raised something in '91 or so at SRI, Nick. And unfortunately, they would not give out their schema so that everybody diverged from there.
Yep. And that's now they're actually working together to fix that.
And the differences in the access mechanisms is just superficial. The thing underlying is the schema.
I agree. Thank you.
So this is Mark Hoster's Aaron. Thank you very much for bringing us to the table. So this is something that the regional registries, Aaron included, has been very much actively involved in making this happen. Andy's been very active, and thank you for contacting him and talking to him about it. The regional registries all know we've talked together about some of the differences, and we're going to work on bringing more consistency to the process. As Rudiger mentioned, There are inconsistencies in some of the ways our schemas are set up, but we're trying to use this as a framework to actually bring things a little bit more consistent to the user community, back out. So thank you again for bringing this up.
Yeah, and thanks a lot for all of you guys for being so receptive and helpful. All right.
Any other questions? All right, then we will finish and thank Matt for his presentation.